Hi, Snail. All the best. आवाज येत नाहीये.
काय करू?
आवाज येतो. वोट ऑफ थँक्स. अरे फोन नाही उचलत आहे. आता लास्ट मिनिट सांगणार ते प्रेझेंटेबल असेल काय माहिती काय कपडे घातले.
ठीक आहे.
नको
आय एम देअर.
तूच कर. असं लास्ट मिनिट सांगितल्यावर कसं करणार? काल सजेशन द्यायची होती.
हो बघ.
कॉल करत होती तिला कधीपासून, आता पण ट्राय केला, ती उचलतच नाहीये.
ओके.
त्याची झोपेतून उठून बसेल काय माहिती लेक्चरला.
हो आता काय अंघोळ नाही केली तरी चालतं. नितीन सर काय करताय? माझा नोटपॅड दिसतंय का?
नाही दिसत आहे.
आहे ना.
तू बघून बोल, काही प्रॉब्लेम
हो
नाही.
हो बघूनच बोलावं लागतं.
काही खाल्ला का?
हो नाश्ता करून. नितीन सरांनी काही खाल्लं नाही. काय वेळ आली आहे, पूर्ण रेडी होऊन आपण लॅपटॉप पुढे बसलोय.
उपवास आहे उपवास. काय खातायत?
चालेल, उपवासाला चालेल.
कॉलेजमध्ये पण घेऊन यायचे ना फ्रुट्स कट करून. हेडफोन्स लावू की नको लावू मी?
हे साक्षीचा फोन येतो, 1 मिनिट हा.
हा नितीन सर,
हम्म
हेडफोन्स लावू की नको लावू?
बघा लावा.
आता आवाज क्लिअर आहे ना माझा
हेडफोन यासाठी बोलते कारण मग सेमिनार पूर्ण घराला ऐकवलं ना तुम्ही, म्हणून म्हटलं.
काय सेमिनार? हा आता असं आहे बरोबर?
बरोबर आहे.
मग हेडफोन्स लावू. हे पण आहेत माझ्याकडे, खूप व्हरायटी आहेत हेडफोन्स.
सर आलेले आहेत.
आन्सर आले.
प्रदीप त्रिपाठी सर. गुड मॉर्निंग सर. गुड मॉर्निंग प्रदीप सर.
Good morning, sir.
गुड मॉर्निंग.
Yes
Am I
sir,
audible?
I just want to ask you, you are going to present the PPT now?
Yeah.
Okay, so I have make you co-host, so you have the rights to share your screen.
Okay, sure. So let's check it. I will share my screen. Yep.
Yes, you can.
Yeah. Okay, it's working. So I
Yes
will
sir.
stop it. Yeah.
చిన్న డబ్బాలో ఉంటుంది, పసుపు తెచ్చింది ఒకటి. హలో ప్రదీప్ సార్.
Yes, ma'am.
I am Sharda. We were on phone, we spoke on phone, we have emailed each other, but we did not meet. So I just
Yes.
wanted to introduce.
Mm-hmm.
Uh, so, thanks for accepting the invitation. Just 3-4 days back, I invited you. Thank you.
Yeah, that's fine. It's it's pleasure to be here, ma'am. Thank you.
Yeah, okay. And your PPT is also shared, so any problem in between we can run from our side. That is not an issue.
Okay.
Here on Zoom, some students will join along with teachers.
Mm-hmm.
Everyone else will see the live YouTube. And if
Mm-hmm.
there are questions there, I will read from YouTube and I'll tell you the questions at the end. Fine,
Okay,
because
perfect.
it has a capacity of 100 and we cannot allow everybody to join.
Okay,
There are
that's fine,
around
ma'am.
200 students we invited. So let's see how many join here and remaining will join there.
Okay, ma'am. Sure.
Will sharp start at 10 o'clock. And this is Nitin sir who has emailed you the link, and he will be handling all technical part in case
Mm-hmm.
you want to talk to
Hello
him
sir.
any
Hello,
technical
sir.
issues. He is Nitin Pawar, and she is Snehal Deshmukh. Snehal ma'am, she will be hosting, introducing you and all.
हॅलो सर, गुड
Hello,
मॉर्निंग.
Manjut
ma'am.
ma'am is there.
Good morning.
Yeah, Manjot ma'am is there.
Mm-hmm.
Rikisha
Yes
ma'am is
sir.
there, and there's one student Milisha joined now. So we
Okay.
will soon start. We will start at 10 sharp.
Okay, sure, ma'am.
Participants, please mute yourself. So let's start. Uh, Hello, everyone, and a very good morning to all of you. It gives me immense pleasure to welcome our very esteemed guest speaker for today's session on Introduction to Big Data. Before I begin with formal welcome, I would extend my greetings to our management members, our dear Principal Ma'am, Dr. Mala Pandurang, and our RUSA Nodal Officer, Mrs. Vidya Subramanya. Well, now, to speak about our guest speaker, Mr. Pradeep Tripathi, who is Lead Data Solution Architect at HCL BV Netherlands. He is an industry expert in big data, artificial intelligence, machine learning, and business analytics. He has experience in successfully implementing solutions for Fortune 100 enterprises. As a data enthusiast, he has worked on solutions in healthcare, travel, insurance, media, and other verticals for enabling organizations to make data driven decisions. Now, I request Mr. Pradeep sir to lead us with the session. Thank you.
Thank you, Snail ma'am, and good morning, everybody. So quickly, I will share my screen. Okay. I hope my screen is visible to everyone.
Yes, sir.
Okay, perfect. Thank you. So let's start. So let's start with the agenda. So what basically we are going to cover in this 1 hour or in this session. So today agenda is what is big data. First, obviously, we are going to discuss how we can define a big data or what is big data actually. And then next one, describe data trends. Basically, there is a data trends in industry. So we are going to discuss that again, volume, velocity, variety. There are other V's also. We are going to discuss that one also, but again, it's related to big data. And then also we are going to discuss popular use cases. Use cases means industry use cases. Basically, industry is trying to solve X. And then next one, we are going to discuss the importance of big data. Why is it popular? Why is it trending? Right. And then next one, overview of connected data platforms. So big data, what is big data? Then what kind of challenges industry is facing on the big data side? Then how these data platforms are capable to solve that problems, or uh, capable to overcome that challenge. And then the most important, definitely I will give an overview how data industry works actually, what different kind of roles are available, and what kind of skill sets is required if you want to work on the big data or in the analytics side. And last, I think 10 to 15 minutes I will keep for the QA session. Or if you guys have any session, if you guys have any questions, so obviously you can ask. And also, I would suggest, please feel free to interrupt me anytime. Just ask your question. That's absolutely fine. Yes. Okay, so let's start with what is big data. So basically, to give an idea, so basically, where did the phrase big data come from, and what does it means, right? So maybe you guys have already read about it, or if you Google it, so you will get so many definition. But this definition, which basically I am presenting right now, so that is actually given by Dog Lenley. Basically, Dog sir, who basically came with an idea, and that's why generally we follow his definition. He is working with White House actually right now. So the term big data come from the computational science. So basically we say, what is big data, then obviously it's a kind of scenario. We cannot say that it's a kind of tool or technologies. So basically we describe it as a scenario where the volume and variety of data types overwhelm the existing tool to store the data and process it. I mean, sometimes it's one thing only to store. Industries are not capable to store the data, and sometimes or it's something like industry has huge amount of data, but they are not capable to process that data, or they are not able to bring any insight from the data due to their existing infrastructure or existing tools basically underlying they are using. So we are going to discuss volume, variety, velocity later on. So that is basically big data. So how you can define big data? So basically three V's are given by Doc sir. So Doc sir, basically, so I'm going to first discuss three V's, and some people also basically discover three V's later on, but we are going to discuss that later on. So first one is volume, second one is velocity, and third one is variety. So let's discuss one by one. First, volume. So basically, volumes refers to the magnitude of the data being generated and collected. So it's both. So when you use any social media platform or any digital application, so that means you generate a data. We generate a data, right? As a human being, we also contribute on the generating the data side. And obviously the provider means social media platform provider, or the platform you are using, for example WhatsApp, right? So basically WhatsApp provider, like now it's a Facebook, so basically they collect our data, right? So basically it's increasing at a faster rate from terabytes to petabytes. So when we talk about big data, so obviously when we have a data in terabytes or petabytes or zettabytes, then we say it's big data. So that is the first V. So there basically we refers to magnitude of the data. That is the main point. Basically what happens, so with increase in storage capacity, I mean what can not be captured and stored now will be possible in future. So sometimes due to storage limitation of the storage capacity, we cannot store all the information, but going forward we can store that, or we can handle that situation also. So that is first we basically that is volume. uh, uh, any questions? I just I can.
I think that is
Okay,
by mistake somebody has unmuted. You can continue,
okay,
sir.
okay, thank you. So let's talk about the second V. The interesting one is variety. Variety, as name refers, actually, it's different types of data. So obviously, we have a different type of data when we work in the data, with the data, or in the data field, actually. So again, we talk about two things: data being generated, and captured, actually both. So when we talk about a type of the data, so we have three types of data. So the first one is structured data, second one is unstructured data, and third one is semi-structured data. So let's discuss one by one. This is very important. And what is structured data, what is unstructured data, what is difference, and is there any challenge, or so for example, if we have unstructured data, then what kind of challenges we are facing. So let's first understand it, then we can discuss the challenges we are facing with the data. So first one is structured data. So when I generally see structured data means if you can define data models of your data, that means your data is structured, right? So what do you mean by data model, actually, right? So when I say data model means you can create a schema, or technically if I say table schema, right? So create a statement. So you have a one CSV file, and then you have to load that data into your any RDBMS system. Let's take an example of MySQL. So before loading that data in the MySQL server, you have to create a table, right? So that is a basically schema. You define a schema, that is basically we call data model. So basically, if you can create or organize data using predefined data models, because in CSV you already know your data model, so obviously you can define it. So that is structured data. So structured data, for example, any relational database, Excel database, or CSV files, these all are the basically structured data examples. But the interesting fact is in industry, right? So, or you can say that the 5% data is only the structured data. So that is really interesting, because you are going to get data. Out of that data, only 5% data is structured data. What about the other 95%, right? Unstructured, or is it semi-structured? So that is structured data. And the next one is unstructured data. So unstructured data cannot be organized using predefined basically data model. uh, so I mean, you cannot define any data model to store your unstructured data, or to store your data. That means it's a unstructured data. For example, videos, text, and audio, right? So for example, day to day, we all use actually WhatsApp, right? So we send text messages. So just I have quick questions to you all, guys. So because day to day we use this application WhatsApp, and obviously we send messages, and we also share some kind of contents like video and images, depends what kind of person I am, right? So is text messages or WhatsApp text messages are unstructured data or not? So think about it. So for example, the text which basically we send or we exchange, actually that is part of unstructured data, because we cannot create a schema of that text, right? So we, because we have a different language, or we have different acronyms we talk about with each other. For example, someone writes for thank you ty, someone basically write y question mark for the y. So that's again unstructured data. So video is again, and audio, these all are the examples of the unstructured data. So let's now talk about semi-structured data. So semi-structured data fall between category of structured and unstructured data, right? So for example, I would say if you can define partial data model, then it's a semi-structured data. So as you all are from technical background, so definitely you guys aware about JSON or XML. So those two basically file format are example of semi-structured data. So where you have a partial data model, you can create, I mean, some extent, till some extent you can create a data model. So that is a basically semi-structured data. The last one, velocity. It's interesting. We call it real time, or so velocity refers to the rate of generation of data. So for example, growth is exponential, right? Data growth is exponential. So for example, what do you mean by generation of rate of generation of data means? So for example, I am one organization and I have one application. So in 1 hour, I am getting, let's assume, 1 petabyte data. In 2 hour, traffic is increased. Now I'm getting 2 terabytes data. In 4 hour, I'm getting 8 or 10 terabytes data, right? So that is a rate of generation of data. It's exponential, growing exponentially actually. Traditional data analytics, uh, obviously when I say traditional means earlier, or you can say that before 2005. So our data analytics was all about periodic update, like a daily, weekly, or monthly. It wasn't real time, but due to like a big data tools or technologies or kind of data platform are available in the market, so we can actually do it in real time actually. So excuse me. So few domains including retail, telecommunication, and finance generate high frequency data. So telecom, for example, when we make a call, actually they store our certain information, right? Or when you go for the grocery shopping, like a Big Bazaar or Hyper City or DMart, so actually they store some kind of information. So their frequency is very high of the data actually. And obviously mobile is playing very big role in the generation of the data, right? So to generate a data, basically mobile apps or demographic data, your location, your transactions history. So generally we use that kind of information to create a personalized content. So for example, you are looking for product ABC in Amazon, and once you are done, so you close that application for example Amazon, right? And then you basically you want to be visit your Facebook account, then you open your Facebook app, and in Facebook app you see similar product ads. So that is again a real time or example of the velocity kind of things, or you can say that velocity big data. So these kind of applications. So sometimes in industry we work in one V's, sometimes we work or we just work with two V's, or sometimes we work with three V's. So in each V is very big problem in industry, and we are just trying to solve, or we are just trying to add value using the data. So let's talk about the challenges. what kind of challenges we are facing right now due to 3Vs. Let's discuss first V, that is volume. Obviously, first we issues include storage cost, but nowadays that is not a big challenge, right? So, for example, storage cost is very cheap nowadays. Very cheap means if you go back not more 5 years, if you think about one TB hard disk cost was, I think, 8,000, 9,000, but nowadays 1 TB hard disk cost you like 4,000, I think. So it's now cheap, but obviously cost matter when we have a data in petabytes or terabytes, and data is keep growing. So obviously cost is going to increase. So that's one factor basically. Two are main important actually. Basically, when you have used amount of data, let's assume if I have 1 TB data. Now if I cannot filter, or if I cannot find a element or any kind of insight or information from the data, so that data is not useful for me from the industry point of view. If you think about it, for example, I mean, uh, my application is generating so much data, and I'm just collecting that data and I'm storing it somewhere. But after storing it, I cannot process it. I cannot filter it, or I cannot find any relevant information, because I do not have a tool in place to process 1 TB data or 1 petabyte data at once. So that is a challenge, right? So if you cannot process it, so that there is no value, so that data is useless. That is a kind of junk for us, right? So that is another challenge. Storage is fine, but this is the main challenge, second one, which I am talking, to process huge amount of data. And the third one, the ability to analyze data quickly enough. So for example, you have 1 TB data, and you are saying, okay, that's fine, I can process this data in 1 month. Again, it's useless, right? So because uh, you cannot, I mean, you are behind 1 month back. I mean, you cannot make any decision right now or today. So again, if you cannot analyze your data quickly, that means if you cannot process your data very quickly to generate the reports, or to build a machine learning algorithm, to build any predictive or descriptive analytics, whatever, that's fine. But if you cannot process it very quickly, so that means you cannot add any value in your business means so for example, ad, we basically, you guys see the ads, or for example, right? So that these are the basic challenges we are facing with the volume, right? So now let's move on, and let's talk about a variety again, type of data actually. So obviously, so when you have a different type of data, so it's obviously matter how you are going to gather, where are you going to store that data, do you have system in place who can store, or where you can store all type of data, structured data, unstructured data, semi structured data, right? And then how you can link your structured data, unstructured data together, and then you can add value in your business. And then obviously doing the join, basically we call it match, and then performing some kind of cleaning operation, then transformation across the system. Because if you think about a one company has multiple application, data is coming from multiple places, and they are storing that data. Then basically they have, basically in industry we have to basically we have to match that data, or we have to link that data. Then we can add actually value, or value to the business, right? So for example, relationship or hierarchy. So for take example, in your college, you guys have a hierarchy. So in data also we have a hierarchy, or in the business. So to add a value in business, so definitely we uh, need, or we need a mechanism where we can connect and correlate data relationship, and obviously hierarchy also. So there are so many things if you want to add value in the business. So let's talk about the last one, velocity. What kind of challenges right now we are facing? So, uh, velocity basically not reacting quickly enough to benefit from the data. So again, you have a data. So for example, a change in political leadership could cause a peak in social media, and you are extracting those tweets or Facebook memes content from the social media platform, but you cannot process it, or you cannot make any decision using that kind of data. So not reacting quickly enough to benefit from the data. So for example, you have one application and it somehow it went down, and your users are coming to you and they are saying, okay, your application is down. That is not a good thing. So as a company, as an organization, first automatically I should able to know my application is down, so I can inform to the users, hey, there is something happen in our system, and we are looking into that. So that's what industry wants, right? And that's what makes sense, exactly. So obviously, so that is not reacting quickly. So I mean, in past, if you remember, in one day Instagram went down and then it was trending in the Twitter actually. So those are the examples, actually not reacting quickly enough to benefit from the data. And obviously, data flows tend to be highly inconsistent with the daily, seasonal, event trigger changes in peak load. So obviously, like we say, for example, in business, or if I have one shop, then we say this is a season, this is my season, right? So for example, I have one big book store, then maybe June, July, August is a season for me, right? So obviously, I'm going to get more customer on that time. So same thing happen in data also. So we have a basically season or some random event which triggers basically changes in peak loads, like a political leadership change or something like that. So right, we have also those kind of things in the data also. So this is just give you all an idea actually. So if I talk about three things, that is mobile device, and then human content. Human content means we generate that data actually using certain application. Obviously, directly we cannot generate data. We need a digital platform, right? But human content means, for example, I'm using WhatsApp and I'm sending or I'm exchanging some kind of information, messages, audio, video, right? So that is like a human content. And then IoT. So basically, in 2020, basically they have predicted EMC.com data is going to be 44 zettabytes. In 2013, it was basically 4 zettabytes. So you just do not see the numbers. If you think about zettabytes, it's a very big unit for us. But if you think the growth rate actually from 4 to 44 in 7 years, so that is a like a very big growth in terms of the rate of growth, if you see, right? So to give a more idea about it, so this is a graph again. Source is already mentioned in the PPTs. You guys can, after this I mean session, you guys can go and explore more about or you can read about it. So for example, this basically one axis, that is basically y-axis, so that represent data volume in zettabytes, and then x-axis basically represents the years. So if you see, in 2005 it was a zero point 0.1 zettabytes, even it wasn't 1 zettabytes, but in 2010 it was 2 zettabytes. And if you see, in 2015 it's now it was 12 zettabytes. 2020 they have predicted 47 zettabytes. And if you see, 2025 it's a 163 zettabytes. That's a very big numbers. I mean, no one knows what is going to happen actually. If you think of nowadays, I mean, everyone is using WhatsApp, but that wasn't case if you go back 5 years or 6 years down the line, right? So that is a kind of change or generation of the data also. So obviously, So obviously, what are the challenges right now industry is facing, or as a industry we are trying to actually overcome? So first one, obviously, existing data infrastructure, or you can say that architecture or infrastructure means is in terms of storing it or processing it, incomplete, irrelevant, and expensive. Obviously, when we process data in zettabytes or petabytes, obviously there is a cost associated with that. Then obviously this is the largest business innovation cycle in history. So we say it because we are seeing it actually right now, because largest business innovation means ad industry or anything. You just personalize content, recommendation system in Netflix, right? Maybe you guys aware about a data breach which happened at uh, when it's happened, I think when election was happening, US president election, Trump won that election, and obviously they used Facebook to influence the people. So that is also possible. So you can see, I mean, basically using data you can make constructive things or constructive decision or products, or also you can make a destructive things or products to influence the people, and you can do whatever you want. So that is also a one dark side actually. And obviously many companies, I mean, even nowadays I would say basically every company have a plans for the big data. How basically they are evaluating their existing infrastructure or architecture, and they are looking to create a new data platform to overcome these problems actually. So obviously we know data holds actually too much value, so obviously we can use it. So there is always we have to, I mean, there is a cost, then it's fine, but as long as we are adding value, so it doesn't matter. So we in to sustain in a market there is a competition. So if we the competitor is there, and obviously we need to capture that data, then we need to process that data, then we need to add that value to our business to compete to compete with others. So nowadays basically how industry is tackling basically this situation, or in industry there is a most uh, common basically platform, you can say that data platform basically nowadays. And I would say 90% data industry is using this concept actually, and they are trying to create a basically data lake. We call it basically data lake. So data lake, so if you ask me what is data lake, then just I would say data lake is a centralized repository of your organization. So for example, so Reliance, let's take an example of Reliance. Okay, now Reliance has a multiple verticals, or they have multiple products also in place, right? So they have retail business, they have petroleum business, they have telecom business, they have healthcare business. So they have different businesses. But as a Reliance owner, I want to see what is happening. I want a one view, right? So for to see that kind of view, we call 360 view of data. To create a 360 view of data, obviously we need this kind of data lake where we store all kind of information, you can say that. So and data lake, when we design or build a data lake, so data lake can store any kind of data. Any kind of data means structured data. You can store structured data, you can store unstructured data, you can store obviously semi structured data. So data lake is I mean capable to store any kind of your any kind of information. And obviously on the top of data lake, generally in industry we build a processing layer. So to process that data. When we store a data or information from multiple sources in one place, and then how we can process it quickly to build dashboards, or to build basically some machine learning algorithm, or to build any kind of data product. So that is a basically data lake. So if you see in right side over here, so this is like a data lake, so where basically we fill all the data. Means it doesn't matter data is coming from where, we just pull that data and we store that data into the data lake, and then we use that data for example for the machine learning, where we do the predictive analytics, and then we do the analytics like a reporting kind of things, like a descriptive or prescriptive kind of analysis. And obviously data lake give a uh, single truth of the data actually. So there is one source, and just we believe on that source data is authentic, so we can use that information to understand our business, or to understand the business actually. And obviously if you want to do real time data and analytics, or real time analytics, that is also possible using data lake. So and I would suggest, so there is a link in this slide actually. So I would suggest that this is basically from Amazon. I would suggest after this session just go and read about data lake more. Okay, so how data industry works in the data fields or in the big data domain. So in left side, you can see the people. People means you can say that designation. I think we call it designation, right? Like in software, we have a web developer, full stack developer, software developer, Node.js developer. So similarly in data field also we have certain designation. So we call it people, like first one business analyst, second one is data engineering and data engineer, sorry, and last one data scientist, right? And then we have methodology in place to solve any data related problem, right? So basically if you see in the between over here, so it's a kind of unicorn. So you can see that left side there, the data engineers. So basically data engineers are responsible to build a infrastructure or architecture which is required to store huge amount of data and process it also actually. Yeah, obviously to store it and process it. So or to, you can say that to build a data pipelines, scalable data pipelines or scalable data lakes actually. Who build that data lake? So you can say that data engineers are responsible. That is data engineer job, to build a kind data lake or data pipelines, right? So that's what's basically day-to-day data engineers do. And then we have a business analyst. Then I will come to the data scientist. Business analyst is someone who has very good understanding of the domain. Domain means if I'm, yeah. So for example, I have business in telecom, then I have someone who knows basically very well telecom industry, how it's work, how basically what kind of promotion we can give, something like that. So that's basically they have very good understanding of the domain knowledge. Excuse me. So that is business analyst. And then data scientist. Data scientist, again it's a merger of, you can say that data scientist should have some capability of business analyst and some capabilities of data engineering. So data scientists generally what they do, so basically they pick the data which is stored or processed by data engineers. They use that data to feed or to build a machine learning, or to do the predictive analytics, obviously. So basically we call them a data scientist. So basically they know the machine learning or statistics or AI kind of stuff. So they use that data, they curate that data, and then they feed this data to the machine learning algorithm. And obviously in industry also, business analysts in some organization, they do the reporting also, like visualization kind of things, Tableau, Power BI, they build some reports also. So that is again a job of business analyst, but in some company says no, data scientist will do the reporting work also. So it's vary, but to give a high level overview, so that's what basically is happening in industry, or this is how basically in industry we work actually. Then we have methodology like business understanding. To solve any problem, obviously we need to understand that business problem very well, then we can solve it very properly, right? And then obviously we are working with the data, so we need to understand data. And obviously if data is very huge, or it nowadays that is obviously very huge, so we need a capability where I can process that data to understand it data, right? So for example, you have one table, and you have to understand the data, what is inside this table, what kind of information is present in that table. Obviously you do some kind of query like a SQL or Oracle query, whatever you write. So if that is not present, you cannot do anything. So to understand data, we need that kind of platform, again that is built by the data engineers. Then obviously once you understand the business and you have a data understanding, you prepare your data, you curate your data, you mug your data, or you shape your data according to your need, because all information is not valuable. Whatever information is required, so you just take that information, right? So that is a data preparation. And then obviously modeling. The modeling means then you feed that prepared data to the machine learning algorithm, that we call modeling, or AI algorithms, right? And then last one is evaluation, kind of you can say that testing, like in software field we have testing. So here we have a evaluation. We evaluate, we build 2 or 3 machine learning model, then we evaluate those model based on the accuracy, how is it performing based on the accuracy, actually you can say that. So that this is how basically data industry is working nowadays. uh, but there is a big myth in market actually, because nowadays the trending is like data scientist. But data scientist is popular, but in industry, what basically we feel the challenge we are facing. So if you think, so this basically this is a pie chart where basically it's represent the time we spend, the kind of work we do, and accordingly we spend time. So if you see the 60% one, we spend 60% time to cleaning and organizing the data. I mean, if you say data scientists, they are going to create an algorithm, or they are going to use some algorithm, and they are going to feed prepare data. That is 5% or 10% job, but 60% time we spend only on the cleaning and organizing data. So that is again data engineers, basically they do, or they collaborate with data scientists, and they do together. So you can just, I mean, to give an idea where basically we spend more time, it's wrong. So for example, in nowadays in industry, I want to become a data scientist. So it's fine, but you need a certain skill set for that, and you need to understand we spend 60 to 60% in cleaning and organizing data. Sometimes data scientists say, oh, that is not my job to cleaning and organizing data. But okay, that's fine, but that is one thing where we have to spend more time, because if we do not understand data, we cannot do anything, right? So this is just a given idea where we spend more time actually. And now let's talk about opportunities and use cases. So basically, to give an idea, like opportunities, every sector nowadays basically using big data or ML, or they are trying to bring insight from the data. Financial service, retail, telecom, manufacturing, healthcare. Obviously now, due to this corona crisis, healthcare is like a very good field to work with. And in healthcare you will get very huge amount of data. And obviously in retail and utility, uh, oil, gases, and obviously nowadays public sector also using. So for example, in India, we have Aadhaar card system in place. So that Aadhaar card is built on the concept of the big data. So they are in backend, they are using some kind of data lake, or you can say that Hadoop cluster, to process or to store your information. So private sector, obviously they are using it, and nowadays even public sector, or public sector is also started using it. So you can read about there, I have written some huge cases, or you can say that, for example, new account rate, risk screening, fraud prevention, trading risk, maximize deposit. So these kind of things in retail, 360 view of customer. So for example, when you enter to DMart, like, or Big Bazaar, they keep certain offer when you enter on that place only. So that is a again kind of analysis we do, and then basically we put it. I mean, based on the analysis. So for example, keep break beside the egg. So whoever is basically going to purchase egg, so obviously there is more probability they will also purchase the bread. So that's how you basically sell more product to the customer, right? So these are kind of some huge cases. Yes, so that's I think from my side. So now this is a time for the questions. If you guys have any kind of questions, so definitely I would like to answer those questions.
Yes, anyone has questions, please unmute yourself and you can ask, or you can type in the chat box.
Sir, I have one question. As you said that from 2005, they have so much data, almost zettabyte.
Mhm.
Well, how much time that data is stored in a database? Are they going means after applying some algorithm or after getting particular data or particular format data, are they going to delete the unwanted one?
Uh, Actually, so sir, what generally we do in industry, so we store all the data in data lake, and on the top of data lake, when we basically we create a data marts, and we store that data in our databases, and we do not delete any kind of any data. So that is the one advantage we get from the data lake, because we work with our raw data. We have more data, so we can bring more insight, or we can do back forth, we can again go back and if to read data. So on the top of this, we generally create a data marts. We do not delete any data nowadays.
Okay, and second thing that right now we are talking about the cloud technology. That means most of the apps or data are already stored in the server or cloud base.
Mhm.
So, like, if I want to watch a movie, so okay, that movie is available online. But some
Yeah,
people or some consumers are having already that movies in their laptop or in their PC or mobile or in their external hard disk. So that means there are so many data duplications are there.
right.
So,
Yeah.
how can we solve such kind of duplications?
uh, so uh, so in data, so in industry also, sir, that problem still exists. So to solve this kind of problem, what basically we do to solve a duplication problem, so in data lake we store a duplicate data, and according to need of, or we basically of in data lake, so how we basically we solve, we create different data zones. Okay, so generally we create one data zone, excuse me, that is raw data zone. If data is duplicate, or if data is irrelevant, that's fine, we store all the data. Then we create certain other zones like a refine zone. Let's take an example, refine zone. So we read data from the raw zone and we create our refine zone. So in refine zone, between when we move data from raw zone to refine zone, on that time we do basically we remove that data duplication, or we perform the data duplication logic.
Okay, sir.
Sir, I got a question.
Mhm.
Uh, Student want to know that what are the skill sets they need to have if they want to enter such field and make their career here
Okay,
as a
so
data scientist or data engineer.
okay. Basically, so I would suggest I will talk about a data engineer skill set. So data engineering, so one programming language, and in programming language, I would suggest basically Python. Basically, most I mean mostly companies are using Python, and one cloud. When I say one cloud, means it doesn't matter like AWS, I mean Amazon or Google Cloud or Azure. One cloud, that's fine. And then obviously big data technologies like Spark. You can start with Spark, so that is pretty much used in the industry. And SQL is required, because in big data field we have certain system basically, and which basically we are inheriting or inherited, you can say that, from the SQL. So that is a skill set required for the data, basically data engineer. And if I talk about a data scientist, then obviously one programming language again that is common, that is Python, again most popular in data scientist. And in data science, I would suggest statistics is also needed. So basic maths actually. And then we call algorithms, basically. So need you should have a capability to understand algorithm pseudocode and then implement that algorithm, or you can just make it work, that algorithm. And obviously again SQL is required. And actually I missed one very important part in both data science and data engineering. You also need some uh, basic level of visualization, like it doesn't matter using Python or using any BI tool like a Tableau or Power BI. And from the data science point of view, cloud is not required, but if you know it, or if you have that skill set, that's absolutely I mean good thing.
Uh, so, as a fresher, if any student want to join big data, then what should she or he start? The Hadoop or Spark Apache?
Nowadays, for the industry, I mean, Hadoop is kind of outdated, but I would suggest start with uh, distributed system. What is distributed computing actually? To just get an idea about a distributed computing, and then start with Spark, I would suggest. And obviously, before that, uh, SQL is required. So please, I mean, SQL is a kind of mandatory or common in data field.
Sir, even I have experienced students asking me about
Mhm.
like if they want to do some course, they want to do some data scientist course. There are some courses which are in weekends for only 2 3 months. There are for
Mhm.
6 months courses. So exactly how we can decide, or how student can decide what type of course they can join to become a data scientist, or you can say data engineer after BCA,
Yeah.
after graduation.
Mhm. So what basically I would suggest, ma'am. So as I said, so data scientist is a kind of trending in the market. But before doing a data science stuff, I would suggest first join, or you can do it your own data, some kind of data engineering stuff, because that is required in any way, right? And then you can, I mean, for example, first learn any cloud. AWS, or you can use any, or you can learn cloud using your own, or you can use Udacity or Coursera. That's also fine. And then
Okay.
first, second, I would suggest first cloud, then second, master yourself in your one programming language, that is Python, and then you can join any course. I mean weekend course. In, if you think if it is a weekend course, in 2 or 3 months they are not going to make you champ actually.
Yeah, yeah.
Actually, yeah. So, and because it's a very big field, so I would suggest nowadays, generally this is like, I would suggest join some online classes, like a well-known platform like a Udacity. Yeah, Udacity is really good platform. And I mean, people are from the Googles. They are basically they teach or they train people in the data science field. So that is a really good platform to learn a data science or data engineering. And for the cloud and Python, you can learn your own. So because cloud provider AWS or Google or Microsoft, they provide so much material, so anyone can learn their own.
Okay, okay. Uh,
I
they
think,
actually know Python because we have in the syllabus.
okay, I think, ma'am, can we take a last question?
Yeah, please.
Sir, data warehouse and data mining, is it relevant to big data?
Sorry, sir. Data mining and what was first word?
Warehousing,
Data mining and data warehousing is related to.
big data.
Yes, yes, sir. Actually, so for example, traditional analytics world, basically we were using data warehousing. Okay. Nowadays, what we do, first we build a data lake. On the top of data lake, we build a data warehouse.
Okay, so I can say that if we add in our academic data warehouse or data mining, so kind of it will be kind of the base for uh, big data or data scientist.
Yes, then I would suggest, instead of adding sir data mining, I would suggest data warehouse, because that is a core concept. Everything is derived from there in data field actually.
Okay, okay, sir. Shabda ma'am, over to you. Shabda ma'am. Okay, Snell ma'am.
Yes. Sakshi is here.
Yes, ma'am. Yes, ma'am. I'm
Yes,
here.
yes, yes. Yeah.
I would like to take this opportunity to propose a vote of thanks. First of all, a very good morning to one and all present here. Thank you is probably just two words, but it goes miles to show how grateful you are. So, today, on behalf of all of us, I express my heartfelt gratitude to Mr. Pradeep sir for sharing immense knowledge with us. It was really a very informative session, and we students have definitely got so much to learn from it. I would also like to take this opportunity to thank the RUSA team for giving us this wonderful chance to learn through this wonderful session. My thanks to our management members and our dear principal ma'am for encouraging us in every endeavor. Last but not the least, thank you all the participants for making it in such large numbers. Once again, thank you so much.
Thank you, Sakshi. Thank you, Pradeep sir, for giving your valuable time and giving so much knowledge to our students. They will definitely benefit out of it. Thank you,
Yeah,
sir.
yeah, no worries. You're welcome, ma'am. Thank you very much, and have a nice day, everyone.
Yeah, yeah. You too.
Yeah, yeah. Bye bye.